Welcome to whomever may be watching. This is the recorded version of the virtual Helix demo. We're going to be going through just a couple of standard use cases and applications of the Helix product. All of these are prototype or proof of concept level right now, but there are some active development efforts to turn this into an off-the-shelf capability for some select platforms. But what you see before you right now, on the left-hand side of your screen, we have a virtual Windows login. So users, accounts, all alike there. We'll show you what Helix is doing from a capability standpoint to really step up the security, the usability, the access control for this particular workflow. On the right-hand side, what you're seeing is a screencast of an out-of-band end-user device. So right now, this would be one of these users' Android phones. Right now, we're going to pick on the user Carol. So you can see on the left-hand side, she's going to try to log into her Windows account. And on the right-hand side, she has that traditional 2FA or MFA out-of-band device that she'll use to input credentials when she gets asked for them. So we'll go ahead on the left-hand side of the screen now. We're going to pretend to be Carol for all intents and purposes and log into our account. We're going to log in at a particular level. You can see there we have selected the operator box, but there's a couple different degrees of access control or access privilege that we can request for our Carol user account. So we're going to go ahead and just start with operator. We'll get more into depth of how exactly we're striating access against these lines. But as Carol tries to log in on the left side, you can see on the right-hand side, she's getting that MFA push. So again, she's logging in at that operator level. That operator level access policy has specific credential requirements that must be met in order to successfully authenticate. So she's being asked for a PIN number here. We'll go ahead and enter that information into her out-of-band phone. What you didn't see was that we were also parsing information and data native to her specific device. So if she wasn't answering that authentication push challenge on that particular smartphone endpoint, she would not have passed this MFA check. All is well and good on the right-hand side of things. On the left-hand side, we are almost done setting up our PC. Thank you, Windows. Little delay due to the networking side. Again, virtual demo. This is not how it would work in real life, but just, again, uppercase P prototype. But you can see, okay, we passed the MFA check on the right-hand side. On the left-hand side, we now have access to Carol's desktop at the operator level. All is well and good. On the left-hand side of that screen, you can see that there's 3 TXT or text files that are here on her desktop. One of the things that we're going to go ahead and do is open that operator.txt file, just to showcase that, okay, we've logged in as an operator. Carol is then going to access or request access to an operator level resource, and that we can see from this kind of debug window, this kind of peek behind the curtain, if you will, that we were actually, even though Carol on the right-hand side, you see, didn't get pinged with another MFA notification, what this window is telling us is that she was actually re-authenticated right here without any of her input required. So we dismissed this little debug window. Again, a real user wouldn't see something like this in a real production environment, but there we go. We just got Carol access to an operator level resource because we've already proven that Carol can have that operator level access. We automatically re-authenticated her at this little micro perimeter or this little tripwire boundary that sits in front of this particular resource on her operator level account. So, okay, let's X out of this. I think we get the point there. Now let's open this technician.txt file, right? So this is a file that is intended on the organizational level for technicians only. Now, you can see on the right-hand side, we are getting pinged with an MFA notification, right? And we're being asked for a different credential now. So this is the technician access policy, right? The operator level policy was that PIN number and the device ID for technicians. Now it's a password. We're also going to reparse that device ID just to make sure no funny business has happened to the active session that Carol established beforehand. So no session hijacking, no man in the middle, total impermeability to those classic identity-based, authentication-based attack vectors. You can see on the left-hand side, Carol did indeed enter the right password. She is indeed on the right end user device. The debug window is telling us, yes, Carol just passed authentication. Again, different access policy here. This is a technician level policy. What we saw before was an operator level policy. We'll dismiss this window and just prove to the viewer, there we go, we can get access to that technician level document, because not only did we have the right attribute associated with the user account, right? Carol is both an operator and a technician for this demo, but then Carol was able to turn around and say, yes, I know my PIN number, I know my password, I'm on my correct device. So it's a function of what does the system say about the user identity on the back end, and then what can the user actually prove to us through this MFA challenge. That's really the power of Helix that we're seeing in action, right? Is this really granular degree of not only being able to give that front door access, right? Putting a better, stainless steel padlock on your front door versus that classic deadbolt that other things like Okta and Duo might market themselves to be, but then offering protection to every door, to every room inside the house here, right? That's essentially the vision we're putting forward for Helix in that granular, dynamic, conditional type of access control that we're really spearheading and innovating in this market space. Okay, that's all well and good. Let's go ahead and we'll log out. Let's just do this with a different user to showcase that we're able to kind of, this is not all just hard coded. This is a real dynamic prototype that's able to work in this Windows environment here. Sweet. So we'll go ahead and log in. This time let's pick on Alice. Let's get Alice in there. We're gonna log out of Carol from Helix and log into Helix as Alice. So we'll get her established. We're technically enrolling Alice right now because in the demo that we have set up, these are not pre-canned users. These are ones that we can actually put into the system in real time. So what we're doing here is on the right-hand side, Alice, let's say we just onboarded to our company. We onboarded her as a user. She's enrolled in the system on the back end. Perfect. We're going to get Alice access to her desktop now. We're going to go ahead. Let's try and make her a manager because she doesn't have that attribute associated with her account. So just to watch her kind of get kicked back to the curb a little bit. There we go. So Alice just tried to kind of overreach or overextend her privileges on the network, and Helix steps in and says, no, I don't have any data for Alice at this level, so just immediately reject this. Again, it's kind of, there's a two-phase of access control here. It's what does my definition say on the back end, and then what can the user device pair prove to me is true about how they can answer this access request. All well and good. We'll get access, or Alice the level of access that she actually has, which I believe is operator level. And we'll go ahead and push this MFA notification through once. And there you go. She does have data on the back end that says, yes, Alice's user account on this device does indeed have an operator attribute. We'll go ahead and send her that MFA push, check to make sure she does indeed know that PIN number that she enrolled with. All is well and good. Pass that MFA check on the right. Eventually, we'll be connected to resource access on the left-hand side. Again, nothing that Helix is doing that's slowing down the processing speed on the VM on that left-hand side. It really is just kind of a consequence of the speed of the network in between them. For all intents and purposes, Helix's role in this is finished, right? Helix was asked to verify Alice up to this particular privilege level. We did that accordingly so and proved that, yes, it is indeed Alice on this device with this privilege, so on and so forth. And boom, on that left-hand side, now that Windows has finally woken up, Alice has access to her desktop. We could do this all day, logging in and out with different users, going down into the desktop and clicking on files. But what we want to showcase now is that this applies not just to this IT world, right, of just kind of desktops and virtual computers and files. One of the other prototype integrations that we've done is actually with something a little more analog, being kind of the voice side of things. So we're going to go ahead and just kind of pull up one of our partner platforms, being Redcom Sigma. And so what Sigma does is voice, video, chat, radio interop, file transfer, all kinds of fun communications, command and control for the military, for tactical echelons of the government. But how we're going to use it here is that actually around some of these pre-standing conferences, some of these pre-configured voice conferences, you can see on the left-hand side, I've got my operator conference, I have my technician conference, I have the manager's conference. Around each of those resources, we have those access controls in place like we showed with the files on the desktop. So very similar logic here. to dial into, let's say, for example, the technician conference, which we'll go ahead and do on the right-hand side here. And what you're seeing on the phone now is just that dialer for the Redcom Sigma platform, right? This is how you place phone calls in a Sigma-enabled environment. But when we place that technician level conference, you can see we're going to get challenged now with a technician level access policy of saying, we're logged in as Carol for Redcom Sigma, right? So Carol does indeed have that technician level attribute. We're going to challenge her for what that technician level access policy requires, which is that device ID, that password. Boom, we'll scan her. She'll go right into that conference. And as you can see on the left-hand side, we passed the MFA check. We got past that micro perimeter or that little tripwire access policy. Carol proved to us that she does indeed, is Carol. She's supposed to be there. She's on the right device. And there we go. She gets access to that particular resource. Let's just drop out of this call and then jump her into the managers, just so we haven't showcased that credential yet. Just to talk a little bit about, Helix is not all about just pins and passwords and device IDs, right? We have a near arbitrary level of support for authentication credentials. So Carol, again, having that manager attribute as well. She's kind of like our power user in this Helix demo. What she's going to be able to do is not only give that PIN number, right, but now because we're asking for manager level privileges, we're going to challenge her for her employee ID badge in the form of a smart card or an RFID token, some kind of wearable NFC chip, or even a CAC. And she's going to go ahead and scan that right on her user device. We're going to parse, again, data that belongs and is bound to Carol's identity here to prove that, yes, again, it is Carol. She does have that card in her possession. It is the correct card, and it's being read and processed on the correct device. Boom. What do you know? All of that checks out. She's able to get access to that manager level resource because she passed that manager level access policy. And I know that we're talking in terms of job roles here, and you might get the impression that this is role-based access control. Really, this is generic attribute-based access control. These manager and operator and technician tags could very just as easily in the Helix system be I'm passing the BYOD, the bring your own device access policy, because there's some measurable attribute about my device posture or my user account that tells you I'm outside of the office space. In some of our integrations with our design partners, Viasat in particular, we're able to parse more specific data like geolocation and essentially append an attribute to a user profile that says, yes, they are within this predetermined geofence or they're outside of that particular geofence. This enables us to do all sorts of fun things, like change what an access policy actually means. So I know that we saw a PIN and a smart card be required for that manager level access policy. We can change that in an instant to essentially be only a smart card, only a PIN number, or even add more credentials on top of that, right? I know that 2FA is kind of what this looks and feels like from the user perspective, which is by design. We don't want to overload or confuse the user at all, and we want as minimal downtime in training someone as how to use Helix as possible. But as frequently as this could be 2FA, this could be 10FA. This could be 5FA, and it might vary from instance to instance or access request to access request. And we'll do it every single time. It's it's the dynamism, it's the flexibility, it's that ruthless validation of access control, of privilege escalation. That's what Helix is all about from a design, from a use case, from a capability standpoint. So the last thing that I want to showcase here is essentially, okay, how do we manage this? And I'll show you that in kind of two different avenues. So on the left-hand side, we see the Sigma page, right? This is Redcom Sigma, all intents and purposes. This is not the Helix platform. This technology does not belong to ZKX Solutions. But one of the things that we have done with our design partner Redcom and their platform Sigma is make the back end of Helix controllable through the Redcom Sigma interface. So through the Redcom UI, we have the ability to essentially inject these little configuration parameters that send instructions to Helix about what an access policy means, what kind of attributes a user is empowered to ask for, resources of the corresponding type, so on and so forth. That's a huge advantage if you have admins that are trained really well on Sigma, but maybe no identity or access control experts on your payroll. They don't want to learn a new interface. They don't want to learn how to use Active Directory, which is another database integration that we support. They don't want to learn how to use the native Helix backend UI. They just know Sigma and they don't want to learn anything else. We can enable them to, and for other platforms like Sigma, use that native UI they're used to administer and deploy Helix in a way that fits the requirements for the organization that's using Helix to step up its security and its access control. Similarly, we are in the process of developing our own native admin UI to handle these backend operations for the Helix platform. So you can see here, we've only got a couple pages. This is really a technology that's in the alpha state right now. But as we continue developing these pages, as we continue fleshing out those use cases, these pages will get more and more comprehensive. But you can see through our own little backend portal here, we're not only able to just identify what the access policies mean, right? Well, what credentials someone must prove that they are in possession of or know the kind of secret data for in turn to satisfy one of these access policies. We can also see the users and what they are, what kind of attributes that they've been empowered with, right? So we saw Alice get kicked out of requesting access for a manager level resource. It's because she doesn't have that manager attribute. She's just an operator. Similarly, again, Carol's kind of our prototypical power user. She's got every attribute under the sun that we support right now. And we can see that reflected on the user page here. We can use this page to add users, add attributes to users, change what an access policy means, but that's kind of second tier, that's kind of second level stuff that we don't really want to include in this particular video. But if there's any interest there, just reach out to us and we'd be more than happy to spin up kind of a deeper and more comprehensive view of what this demonstration is. Before we kind of just cap off, one of the things I do want to reiterate is that on the end user side of things, so on the right-hand side of that screen, it really looks and feels like regular 2FA. It really looks and feels like regular MFA that we're all used to. But that is where a lot of this magic comes in of the ZKX technology suite, and particularly the Helix product. Even though you have a user putting forward their password, you have a user putting forward their PIN number, because of the patented processes that we've implemented into that particular client functionality, again, processes, algorithms, subroutines that are owned exclusively by ZKX solutions, we have unrivaled security guarantees for that end user. So even if in some instance, let's say Carol accidentally had that password fished out of her, right? It wouldn't be super hard to guess. Password is not a very secure password in the grand scheme of things. We know and understand that. But even in the event that someone was able to guess that password or fish Carol away from that password, it still would have no ramifications in the ZKX Helix system because of the protections that are baked into those patented processes. We're leveraging something called a zero knowledge proof, where essentially that password is just one of many keys in what's essentially a two-key system. If you're familiar with like the nuclear football, you need those two titanium keys to really send the go signal. It's the same idea here. It's not just someone being able to guess or parse Carol's password from her. It's also a function of being able to be in physical possession of Carol's device. It's essentially those two cryptographic elements recontextualizing themselves in the zero knowledge proof to prove, yeah, okay, this really is Carol. This is how at the top of the demo, I mentioned that those man-in-the-middle attacks, those session hijacking schemes, we're impervious to, simply because we're using under the hood a zero knowledge framework that is so much more cryptographically robust and has way higher standards of secure workflows than our competition, Okta, Duo, Microsoft Authenticator, so on and so forth. That we just we're essentially bulletproof to those classic methods of authentication, identity-based attacks that are so prevalent and still eating everybody's lunch to this day. So again, that's like If the policy switching was level 2 stuff, the cryptography is like level 5 stuff. If you got interest in that, reach out to any one of us on the call here. We'd be more than happy to take you through. We'll link you our patents if you don't believe us yourself. We've got the U.S. Cybercom, the NSA, and the USPTO saying that we're doing something that other folks aren't doing to a different degree than we've seen before in the market. So if you want that validation, just ask. We'd be more than happy to give it to you. But other than that, thanks for watching, and just let us know if you've got any questions or want to see anything else in any deeper depth.